All right. Well, welcome everybody. I am Chris Armstrong, President and Chief Architect of APG. I'll be the MC as well as saying a couple things through the presentation as our normal host Brian is unavailable today. So this is part 4 of our webinar series on model quality and validation, moving from that to governance. And this is our last in the scheduled series. It's possible we might do some more, but talking about governance automation pipelines. And as previously, honored to introduce our co-speaker and leader of the webinar, Dr. Istvan Roth from the IncQuery Group.
Yeah, thank you very much, Chris, for the introduction. As last time, welcome everyone, and thank you for joining today. We will be covering a pretty exciting topic, actually one of the personal favorites of mine, which is governance automation pipelines. Just to kick it off, very brief introduction again about IncQuery. So some of you, or I hope many of you, may know us from the MBSE community, which we've been working in for many years now on various different topics, be it complexity challenges, MBSE adoption, quality assurance solutions, custom-made tool chains, and so on and so forth. So a lot of that experience has been condensed into the quality assurance product, which is the IncQuery Validator. That's the topic of our presentation for today. Chris, back to you.
Yep, and Chris Armstrong with APG. Again, won't dwell on this since we've done this 3 times before, but ultimately what we're here to do is to help people adopt industry standard best practices through our participation in standards organizations and contributing advancements to those standards back to those organizations. So we're going to continue our discussion and get it grounded in model quality. So in our first 3 webinars, we talked about different dimensions of model quality. Ones that were free from mistakes, missing meta properties or things being accidentally connected to the wrong things or using the wrong relationship. Making sure that we're conformant to whatever methodology we're using for engineering and architecture, as well as our adherence to the modeling languages that we're using, whether that be SysML, Archimate, BPMN, or otherwise. So we kind of like to ground today's webinar around the overall governance in perhaps what might seem like a novel perspective, which is technical debt. And so I imagine most people on the call are familiar with the concept of technical debt, which really came out of software engineering. But ultimately it's about that there are side effects of deferring and postponing when we make necessary changes to things. So the further we postpone those, the larger our debt becomes. That debt, compounds with interest over years, so it becomes more and more expensive generally to address as we move forward. And then sometimes there are fines and penalties when it finally comes due to address those things. So, this emerged out of software engineering, but there's a case to be made, and particularly, from some great work that Ryan Noguchi did from aerospace, and he presented his perspective at the International Symposium in Dublin in July about talking about technical debt in the context of MBSE models. And so again, just a reminder that just like financial debt, debt's not inherently bad, but we want to make sure that we are understanding the kind of debt that we're incorporating into our portfolio, and understand the consequences and ramifications that we have, and we have a plan for it. So, for example, a lot of people consider going into debt for home ownership with a mortgage isn't necessarily a bad thing, although if you can't afford it, it's not good. As opposed to trying to live your lifestyle on credit cards is not considered really a good idea. So again, we're not about trying to eliminate it, but to manage it and make better decisions about it. And so it turns out from some of Ryan's work, the premise I think that I certainly can support in my work is that, reworking models is just not the same as reworking software. In fact, one could make a claim that it's a little more difficult. Part of that is because it's often at a higher level of abstraction. It's about architectural perspectives. So it's more about types of things and concepts, and not actually related to the physical things that are being built. I mean, obviously trying to frame that, but again, tends to be more abstract and more broad in its scope. We're exposing internal implementation details, namely, we're showing other modelers and downstream consumers, those internal implementation details, where normally in software, people just see what is on the outside. They don't ever get to go on to see all the fun stuff on the inside. It tends to be that, reworking models is less lends itself to doing it in bits and pieces. I mean, there are ways to kind of partition it and stage it, but it can be sometimes difficult to just make a single change here without really needing to understand how it's going to propagate and affect a whole bunch of other perspectives. Because models are multidimensional, semantical in nature, even if we are following our adopted method and our adopted standards, automated discovery is more difficult, of course. That is one of the key things that we think we can try to address with the automated model validation solution. And again, there also tends to be more prevalence of defects propagating throughout a model than perhaps might happen in software. And so the claim is that because of the consequences of poor models that are either poorly formed, poorly understood, poorly maintained, that managing technical risk is actually more riskier and more challenging for models than it is for software. And like I said, and it's great coincidence, obviously, why we put this in here to kind of frame and really have a value proposition outside the engineering community, because of course, as engineers and architects, we do want to make sure that our models are free from mistakes, conform to our method, are compliant with our modeling standards. But there's a lot of people that really don't care about that. But if there's a way that you can describe how things are improving over time, or not improving over time, seeing the trend lines that, hey, we're getting better and better, and we're cleaning up things, and it's basically going to have a positive impact, not just for current projects but future projects and programs, is a great, wonderful thing. So from here, I think I'll hand it over to Istvan.
Thanks again, Chris. It was a very, very good intro. And of course, it caters very much to the topics that I will be talking about. So as Chris described, one of the key things to getting a grip on this technical debt issue is to automate certain aspects of the workflow, especially around the discovery of technical debt and quality-related issues, and of course, providing some means to handle the issues that we have discovered and get rid of them and address. So this is actually a set of features that are mostly highlighted in the team and enterprise tiers of the IncQuery Validators for Enterprise Architect. And this is exactly what I would like to show you today, how these features work. So in terms of, let's say, the overall layout of such a setup, of course, this automation is mostly first and foremost relevant in a collaborative scenario where we have several different users on the authoring side who are working on, let's say, the same project or a set of related projects. And there may be other stakeholders in the picture as well, quality assurance experts or reviewers or integrators. Those kinds of stakeholders who are not necessarily in charge of generating the content into the model, but more consuming that either for further work downstream or from the point of view of a stakeholder like a quality assurance aspect or something similar. So in this scenario, the collaboration is typically organized using a platform such as a SQL server or a Git based file version control system. This is what facilitates the synchronization of work that is originating from several collaborating parties. And in the team and enterprise tiers, our validator can be integrated in a straightforward way into such an infrastructure by attaching the validation, essential in terms of functionality, directly to the collaboration platform. So not to the desktop or workstation environments of the authoring parties anymore, but running things on the server side. And the platform on which such solutions are nowadays built, also mostly originating from the software engineering domain, are so-called automation pipeline solutions, or DevOps pipeline solutions. You may have heard this name as well. There is a lot of commercial offerings in this space, but also very popular open source alternative exists. I will be using one such open source platform for one of the demonstrations today. That's the Jenkins environment, but I will also be showing how such an automation pipeline can be organized on a software as a service platform, such as the one offered by GitHub. Okay, so let's take a step further and take a look at one of the demos in depth. The example that I will be using for this demonstration is actually directly related to the previous third part of the webinar. If some of you may have been there, you may remember that we have covered the methodology conformance side of this model governance concept, and specifically how to create custom-made validation rules for the BPMN domain. So this is exactly what will be the subject of the demonstration today. So first, in the first scenario, I am going to be focusing on one of the, I think, highest value added benefits of this automation technology, which is essentially adding the capability of observing quality, not just at a certain given point in time, as in terms of a snapshot of a project, but also how that quality evolves and changes trend-wise as we make progress along the project. So as we commit new and new revisions to the repository, are we fixing things? Are we adding new things? And this, of course, translates directly to this notion of the technical depth, because one of the main functionality of such a DevOps platform, like Jenkins, is to provide a dashboard capability to visualize technical depth at a high level in terms of KPIs, and also to see and visualize its evolution in terms of time, so how that changes in terms of trends. And this could be, of course, very useful to a reviewer or a stakeholder or an integrator, for example, from the point of view of observing how we hopefully reduce technical depth as a deadline for the release looms and gets closer in time. So let's take a look at a similar demonstration as last time. The first step, of course, is from the point of view of our quality assurance expert. They can just log into Jenkins and take a look at the dashboard without having to open Enterprise Architect whatsoever. So all of the violations and the indicators of how the technical debt situation looks like are immediately visible on such a dashboard. The validation report, as I have shown in previous editions of the webinar, is also directly available from such an environment as a so-called artifact that is, on the one hand, generated by the execution of these validation jobs, and is also archived as part of a built-in facility of Jenkins. So the systems engineer can access such a report, and as you have seen in this demonstration, they can download, they can import the report directly into the environment without running the validator locally, and they can also, once they have fixed an issue, use the interaction with the version control system. For this example, we are relying on Lemon Tree by Liber to provide an integrated experience with interacting with Git right inside the Enterprise Architect environment. And once this change has been pushed to the repository, then another execution of a validation was automatically triggered independently of what the systems engineer is doing. This report is generated based on the latest revision of the project that we are working on. And once the validation job finishes, then this dashboard will be also automatically updated. So in this particular case, our engineer has fixed an issue. Therefore, as you can see on the trend chart, the overall number of problems have decreased in between these revisions. So from the point of view of the quality assurance expert, we are on the good track in terms of reducing the overall technical debt of the project. Now, this is, of course, a simplified demonstration. So we intentionally kept the number of violations relatively small, and of course, the whole project just a simple example. But I think you can clearly see what is the real power and the potential of a feature when applied to a real project. Because using these facilities, it's really quick and easy to get a high-level overview on where we are in terms of our work, in terms of key quality measures and the technical depth overall, and what we need to do in order to reuse that. And from my personal point of view, the biggest value added capability of this system is that in order to use this, the only thing you really need from a quality assurance expert's point of view is a browser to go to the Jenkins dashboard, take a look at the reports. You don't need to open the project. You don't need to browse individual results or even look through a detailed report. Everything is to the point and simplified with maximum oversight as a priority. So we can take this one step even further to use the capabilities of the automated validation, not just for observation, looking at reports and trends, but also as a much more intrinsic part of the authoring process. So for this scenario, we will be taking advantage of the more advanced capabilities offered by Git, which is essentially the ability to work with not just a single, let's say, linear progression of revisions, but Git can handle parallel branches of work in progress at the same time. So people with Git can work on several aspects of the same project in parallel, as long as you have a facility to do merging operations. So when work that has been done in parallel by several different authors, like systems engineers, can be merged together in a meaningful way. Now, this is possible with level 3, the product I mentioned before from Liber. But what we can, in terms of the validator, add to this landscape is a very important and very powerful additional capability, which is what we call the quality gate. And the quality gate, as you will see in the demonstration, is essentially the validator itself, but applied in a way that is run, also triggered automatically at certain points in the collaboration workflow, and that provides direct feedback from the quality-related KPIs into the facilitating platform of the collaboration itself in order to help making judgments, for example, when a so-called feature branch, so some parallel branch of work that has been started by someone is good enough in terms of quality to be merged into the mainline. And the reason why I say that this is a step further compared to the previous demonstration is because like this, quality and the automated tracking of quality becomes a main driver of the process itself. So you can organize your work in a way that whatever doesn't meet certain quality criteria will not be merged as long as that's the case. And this is why we use the term gate for this feature. Okay, may have sounded a little bit complex. Let's see it in action, how this looks like from the point of view of systems engineer. So for this scenario, let's assume that our engineer takes a look at the release notes of the latest, let's say, version of the project that we've been working on, the 0.0, and then notice that there is actually an error in that release, which shouldn't happen. That's a problem that we don't want. So we want to make sure, in terms of technical depth, that all the releases that we do or the baselines are free of errors. So in terms of the collaboration platform, he will now create an issue. assigned to himself, in this case, for the sake of simplicity, signaling that there is a problem that needs some fixing. Now, how do we go about addressing this problem? Now, in terms of the Git flow approach, what you do as a first place is that you create a so-called development branch. This is what is happening right now. And this development branch will be then the one in terms of the version control system on which we are going to carry out the work with the aim of getting rid of this error, so fixing the validation error. In order to do that, what we have to do is synchronize and then switch to this branch using the GitHub client. This is what just happened. And once that is done, we can start working as usual. We can open the file in question using Enterprise Architect. Again, the systems engineer will do the same as before. They will access the validation report directly from here instead of running the validator locally, because it saves a little bit of time. So you can import such an HTML file directly into the environment as we have seen before. So here you have the results already instantly without having to wait. And then you can double click and directly navigate to the location in the model, which is affected by this particular issue. This is a sysmod related governance rule. It says the actor administrator is not part of the system context. So we have actually a missing containment relationship. We add it back, hence the error will be fixed. Now we can do a commit and push operation. So this will essentially put this work, this fixed state of the model, back into the version control system as a new revision of the feature branch. This is again done using Lemon Tree as before. And once we are done with this, this is where the interesting, really interesting stuff will kick in, because this is the point in time where the automation platform will start doing interesting things as soon as we ask it to do so. And the way to ask the automation platform is to create a so-called pull request. So this is a collaboration artifact in terms of Git, which signals that, okay, my work is finished. I would like you to consider this for merging. Now, after the engineer has done so, as you can see, GitHub automation automatically triggers this model validation step. And the result of the model validation will be posted directly into this interface. So now you can see that the error is gone. There is no more error. We just have warnings. The model has passed the criteria. So we can actually go on and merge the branch. And once this operation has been done, we can see here that now the branch has been merged into the mainline. So what we can do now is we can create a new release. This will be this bug fix release, technically 0.2.1, derived from the 0.2 release. GitHub also has now facilities to generate the release notes based on what has changed so far. So it's automatically populated here really nicely. And once you publish a release, an additional automation step in terms of quality gate will kick in, which is what we call the release quality gate. Of course, in this case, as you can all already guess, it will yield pretty much the same results because we are validating the same thing again. But imagine if several people would have been merging their stuff before the release, then of course it would need to be checked all together to see where we are in terms of technical data evolution. So this release quality gate works exactly in the same way as before. It takes a bit of time to run. I have accelerated this for the sake of this demo so that we don't have to wait that much, but at the end of the day, it will give exactly the same result, an integrated report directly into the Git system that has a very detailed breakdown as to what's going on. You can download the full report, but also take a look at the high-level result. So this is essentially the way to integrate these capabilities on the GitHub platform, taking advantage of GitHub automation capabilities. And as you have seen, this way, all the capabilities of the validator can be taken to the maximum advantage without doing a lot of manual work, because everything is essentially executed automatically by the collaboration platform itself. This is a very powerful way of using these things, and it's quite common practice in the software engineering world. Of course, in that case, not with model validation, but source code analysis and dependency analysis and security checks and things like that. The enterprise architect validator brings this idea and adapts it to the modeling ecosystem and taking advantage of the capabilities of these modern platforms. So that's it for the two demonstration scenarios for today. I would like to conclude today's session with an invitation to you all to continue the conversation and connect. There will be plenty of opportunities to meet both of us over the course of September at the OMG or in Chicago at the Integrate conference, where we'll be having several sessions, and the booth in Cleveland. Chris and I will be doing a presentation at the Enterprise Architect Global Summit, which is a virtual event on the 18th of September. And of course, you can meet Chris at the IncQuery Western States Regional Conference in Albuquerque towards the second half of the month. Thanks again for joining today. And of course, a special thanks to those of you who have been following us through the entire series of these 4 webinars. And now we are very happy to take any question you may have.
Yeah, and sorry for not mentioning it earlier at the beginning, but of course, if people have questions, feel free to submit them via the Zoom application. But there's a couple here already, Istvan. So it seems like there's a lot of pieces to this automation pipeline. You know, what are which components are required, and so we can better understand if we have them already, and can you guys help out getting it implemented at our organization?
Yes, definitely. So maybe I will use this slide to answer your question. There are essentially two components that you have to have. Number one is the IncQuery Validator itself. So that's pretty straightforward. You get it from us. And you are done. Of course, you have to have enterprise architect as well, but I think that's quite obvious. The main thing, though, is how you build the tool chain or the pipeline itself. For collaboration, you need to have either a SQL installation or a Git repository. I think many of you are familiar with how EA works with SQL. Git is a free open source solution. There are many different implementations of that. Many organizations have it already, either on-prem or as a subscription to one of the software as a service vendors to Git, like GitLab or GitHub, the one that I was using in the demo. And the final and most important component is obviously the DevOps pipeline itself. That's, again, as I said, a lot of the tool chains may have it already. So this is a built-in capability of many of the modern enterprise engineering tool chains. You may have heard about TeamCity or other options, but you can have it as a separate service provided by the IT department itself. Jenkins is a free solution. And it exists as a built-in capability of several of the SaaS platforms as well. And of course, if you would like help with setting all of this up, we are perfectly up to the job. We have a couple of expert guys who have done this for many different customers, not just basic setup, but also integration with, let's say, enterprise grade access control systems. That's pretty standard aspect of this, helping users use this functionality and so on and so forth. So we can help basically all along the way if you need help.
All right, excellent. So we're almost out of time. So one question, and I think probably just a good reminder about, are these recordings going to be available a little bit later for review? And I think what we've done in the past, Istvan, is we've sent a follow-up email to the recording. So you should be able to get that a little bit later once we do some of the post-processing.
Yes, so all of the recordings are available. So the first 3 parts are already posted on the website, and this one is going to be posted there as well. And we are going to be doing a combined version of the 4 webinars together with some of the redundant stuff removed that concentrate really on the essence of the content, and that you should see appearing on our channels pretty soon. So we will be posting that very soon.
All right, excellent. Well, I think that's enough for today. Again, I know whenever I see this ISFON, it always gets me pretty darn excited to really see, you know, the engineering architecture modeling elevated to, you know, using modern collaboration strategies and collaboration tools. So it's great to be able to bring this into the 21st century.
Yes, likewise. Thanks again to everyone for joining us, and I'm really looking forward to continuing the conversation.
All right, thanks everybody.
Thank you. Bye-bye.